Let's draw a function and give examples where the function is increasing, where is decreasing, convex and concave. So if we have our xy axis, x, y, 0, and let's draw the function as something like this. Let's say it would be here and then there, decreasing and start increasing again. That would be our f of x. Okay, first of all, let's see what does the function do until this point. So on this range, well, visually, let's just talk visually now. Visually we can see that the function goes up. It's literally increasing. So as we change our x values, as x takes higher and higher values, the corresponding y values go up and up and up. So the rate of change is positive, meaning that the first order derivative is positive on this range, meaning that the function is increasing, which also mean, actually this doesn't mean, we have to have a look. How does the function increase here? Well, we can see that the function increases until this point. Let's take this curve over here. It's increasing at an increasing rate. How do we know it? By the shape. The shape is convex. You see the curve is kind of inside. It's curving inside, within. So we have a convex shape, which means that the second order derivative on this range over here is positive. The function is increasing at an increasing rate. But let's have a look on this other range. What happens from this point on? What happens from here? Let's take this range until here. Well, the function still goes up, but it goes up less and less. It flattens out, and we can notice that the shape is concave. The curvature is outside. So yeah, the graph is curved out. So that's a concave shape. And when we have a concave shape, well, we know that for a concave shape, our second order derivative is negative. Okay, what happens at this peak, at this point on the top of the graph over here? Well, there is no rate of change because the slope, which is the tangent line at this point, is flat. And when we have a flat slope, we have no rate of change. And indeed, the function is not increasing and it's not decreasing. So it means the rate of change is 0. The function does not change. Makes sense. What happens from this point all the way to here? We go down, so visually we can see that the function is decreasing. And if the function is decreasing, that means that the rate of change, f derivative, is negative. The function is decreasing. Now, how is the function decreasing? Is it decreasing at an increasing rate? Is it decreasing very fast, or is it decreasing slower? Well, we can see that the shape is convex, so the curve is inside, meaning that the function is decreasing at an increasing rate. So if it's decreasing at an increasing rate, the second order derivative would be positive. So it's a convex shape. The rate of decrease is increasing. The more we decrease, or let's say, how to make it simple, as we move along the x-axis, as x increases, the function keeps falling, and it keeps falling at a faster and faster rate. Now, in the last part again, we start increasing from this point over here, where again we reach a minimum point where we have no rate of change, so the derivative is 0 because we have a flat slope. We start increasing again, and it's the same story as before. The first order derivative is positive, meaning that the function is increasing. But how is it increasing? We can see that it is curved out, so we have a concave shape. It is increasing at a decreasing rate because we hit here a diminishing return. We hit a diminishing return point where the line is flattening out. Over here it's flattening out. So the second order derivative is negative because we have a concave shape. I hope this graph makes sense. Go through it again. Make sure you understand at the moment visually. You don't need to go too much into the derivative behind it, but at least visually on a graph, if you understand first, second order, that's it. That's good. That's pretty solid. In the next tutorials, I think you'll go through more and more of these derivatives, but that's the intuition behind them. how is the function changing, and is it changing at an increasing rate or decreasing rate. I hope these videos help, and go through the questions of the tutorials while looking at the formulas we've just gone through. Make sure you know what they mean and where you can use them, and yeah, that's about it. I'll see you in the next videos.